In the depths of winter, there is no better time than now to spice things up. With spice and sweetness in harmony, Parrot Dog's new core range ginger beer is brewed with real ginger juice to be refreshingly satisfying, a little naughty, and very nice. Welcome to this week's episode, where we dive into the world of mass timber construction with our guest and good friend Jordan Robinson from X-Lam. Join us as we explore the innovative potential of timber in architecture, its sustainability benefits, and the exciting projects pushing the boundaries of design. Whether you're an industry professional or just curious about the future of building, this conversation promises insights and inspiration. Jordan's detailed knowledge around CLT and general passion for timber shines through, and it is hard not to want to hug a tree after listening to this episode. Let's dive in. Thanks for jumping onto the podcast this week, Jordan. So for listeners out there that don't know, Jordan Robinson went to university with both Ben and I. Was in the same. You guys were in the same masters group.
Yeah. Just Ben. A group marriage.
Nice.
The band, the myth. That's right. Yeah, absolutely.
As me and Ben went down the light side, Jordan jumped over to the dark side. And what's your role now, George? Head of development or something for
X-Lam? Don't get bogged down on titles, Sammy, but head of business development. So it's sort of the
nice
pre-construction side of the X-Lam business, which is which is quite cool. Get to use a lot of the skills that we learned back in the day at architecture school and apply them on a sort of timber focused more timber focused day to day, which is something that I obviously enjoy.
Nice. Yeah. And the reason we got George on for the chat this week is because we want to just know a little bit more about mass timber construction, really. I'd say that it's still, you guys may have your differing views on this, but I'd say that it's still very much in its infancy in New Zealand, particularly in the residential sector. Starting to make a few movements commercially, but I think it's still got a long way to go and has a lot of potential, and just kind of want to talk about the sustainability aspect of it, its design potential and all that stuff.
Yeah, absolutely.
Yeah. Well, funny story actually about Jordan and
go on
X-Lam, really. Well, it was quite funny. So when we were researching thesis subjects, and we ended up getting sponsored by X-Lam. So X-Lam was really new at the time. Basically, hadn't even started their factory, really. They were just kind of in the early days of prototyping. And so they ended up actually sponsoring us to one of the Prefab NZ conferences.
One of the first one in Taranaki, wasn't
it? Which was awesome. I don't know how we actually wrangled that, to be honest.
I think it was a guy marriage hookup, to be fair, but it was... I was actually reminiscing over that this afternoon before this. Yeah, we're sitting in the back row, and I think the Jack brothers, who were the original founders of X-Lam, were there.
Robin.
And Robin and Ian, and I think they probably looked at both of us and thought these guys have no idea, and sort of pulled us down a direction of mass timber. So it was
So I ended up building, I think it was the first residential CLT building in the country, and
it would have been.
You ended up working with them.
I ended up working with them.
Hey, look at that!
It's pretty funny, really.
Yeah,
comes full circle.
Yeah. Well, that was actually my thesis, so I guess it kind of came, from the back of that, all those conversations that we were having with Jax at the time.
So what led you to that as a solution, though?
I think the reason that we were with guys, we were both really interested in timber construction, essentially. I'd had a lot of experience just building in general, and had built a lot of stick-framed houses, and was really kind of searching for an alternative route, which was the mass the mass customization, which is something that you CNC and customize and go from computer CAD, digital model straight through to essentially print it out and then erect it on site. So that's kind of what I was really interested in, and that's what I did my thesis on, which was design. What did I call it? I can't remember now. Design, fabricate, I think, something like that.
It's been a while. There's a lot of parametric design
Parametric.
in it as well, Ben, from memory.
Yeah, we were thinking about how to make it flexible, weren't we?
looking to expand it and obviously have the BIM component, which obviously wasn't necessarily new, but it was still emerging into the form that you guys more so use it on a daily basis now. But I suppose it was kind of that sort of merging of production technology and obviously computer software for design. And I remember that day we went to the X-Lam facility in Nelson, which is no longer in its current form. Obviously, X-Lam's now moved offshore to Australia, but it was like a wonderland. This CNC machine the size
the machinery.
It was immense, and I guess there was this view at the time that you could do anything, and you can. That machinery allows you to do so much from a off-site manufacturing and prefabrication perspective. So it was awesome to see, and awesome to see it here in New Zealand, I guess.
What is it about CLT and I guess that integration with BIM though that makes it as a design solution or as a design material solution that much better than just stick framing or any other form of construction, steel, concrete, or anything like that?
Look, I think it's
let's put the sustainability aspect aside. For now.
I think probably its emergence has probably been more in alignment with the advancements in BIM technology, to be fair, especially in the Southern Hemisphere. And so as part of that the capability of that design environment and the capability of technology that feeds into production and mass production for things like CLT and glulam and that sort of thing have probably risen at a similar time. I guess things like stick frame, those traditional sort of methods of construction are, I don't know, I suppose they're fairly well ingrained in sort of the fabric of design and construction, and especially in New Zealand, especially residential, that stick frame mindset 3604, you guys will be using it on a daily basis now, and there's nothing wrong with that. It's
industry standard.
It's industry standard. It's known across the various sectors, and it's, if it ain't broke, don't fix it. But I suppose there's a level of innovation that some are looking for, and I think probably in this environment that we're in economically, people are looking to do things in a different way, which technology is obviously a great way to achieve that, I suppose.
What is it about CLT that gives you that flexibility?
Well, it's kind of like a one-stop shop, right?
Yeah.
The thing with stick framing is it's actually quite a few components that make up one panel. Whereas the great thing about CLT, and this is kind of what captivated me originally, is essentially it's just like one big piece of timber that you can cut various elements out of. And nowadays there's even really clean details where you're essentially like putting the insulation on the exterior, creating like a jacket. So it's actually really well insulated as well. So that whole concept of like, okay, cool, we can make parametric models of these wall components, basically like turn that into like data, feed it to the machine, and then cut it out and then send it to site. And I think like the original one we built, and we were just students, and we got a lot better after that. But the original one we built, I think it took us like 3 days or something. So it was very fast. Don't get me wrong, the stick framing technology in this country has definitely improved a lot, but it's still like you got to lay out various components, and you got to stick to the 3604, the building code. Whereas, I don't know, something about that big slab of timber, and aesthetically, just really, really liked the
I like
end
that.
finish.
I like that materiality, that really raw materiality nature of it. Is it still limited to, and this may be my naivety, or maybe just lack of understanding of how far you can push this, but is it still essentially like bound to an X and Y axis as a material? Can you, this guy's harkening back to like Gerard, our conversation with Gerard last week about hydroforming, can you also like steam form it as well? Can you create, can you get the Z-axis into it at all? Or is it more, you can do that by lattice work and all that sort of thing?
Yeah, look, in terms of the CLT component, absolutely, it's very much a monolithic, construction method, so panelized. I mean, if you throw design and money at anything, you can make it happen. It's not commonplace, but I suppose in terms of that sort of 3D component that you're talking about there, and actually moving away from just a 2D format and Glulam and LVL are probably more akin to that, where there's a lot more sort of scope in terms of design for complex geometries and that sort of thing, and high intensity machining. In terms of CLT, look, we in terms of mass timber as a whole, it's all kind of one of the same family. But I think that very bespoke nature it generally lends itself to Glulam and LVL.
Yeah, I was going to say that was going to be my next question. Like, what's the difference between LVL, Glulam, and CLT?
One of the great things, though, so the way that CLT is made is essentially it's a run of varying lengths of timber that are just gauged to the same dimensions and are finger jointed together. So when they're joint together, it's basically just like an endless cycle, an endless run of timber. Then it's chopped to the right length, and then obviously it's kind of one layer goes down, then a adjacent layer is glued down, then another adjacent layer, and that sort of thing. So that's how you get that cross-lamination. But it's actually, the glue that gives it all the strength. So it's quite cool. I really always quite liked how it's just made up of like those waste lengths that are never used in the industry. So nothing, anything that's under 2.4 meters or 1.2 or whatever, it's all just little bits of timber kind of joint together and recycled essentially. So always kind of liked that component about it.
Yeah, that's right, Ben. I mean, you look at most CLT manufacturers around the world, often they, not always, but often they have very strong alignment with sawmills and that sort of thing, because as Ben's alluded to there, the recipe, if you like, in terms of those alternating laminations, they're not always the same strength class of timber. So typically, and this is a very basic description of it, but typically in terms of the spanning capabilities, if it's a 3, 5 or 7 layer, gives obviously considerable benefits in terms of the primary direction. So the primary being the direction that the lamellas are spanning, and then the alternate, the cross-lamination component is generally a lower grade fibre because it's doing less. So generally in sawmills, especially in New Zealand here, radiated pine, we get a lot of SG is pretty standard for the residential framing market. And so as a result, there's typically a lot of low-grade fibre that comes out of the recovery of a log.
Yeah,
and,
right.
If you have the ability to create value out of that and put it into a product like CLT or LVL, typically it's CLT, it's got a better use case for, then there's obviously a better recovery there.
So just to clarify, so Glulam is similar to CLT, but they're all run in the same direction. So the timber's kind of stacked to create a beam, most common. And then LVL, which is laminated veneer lumber, is larger bits of plywood cut up. So the veneer is glued together. And but all of them essentially get most of their strength from the glue itself.
You touched on an interesting thing, both of you guys, just before, how you're kind of saying it's essentially made of waste product. And George, you mentioned it being sort of the leftover remains from the milling process. I'm just thinking, and it's something that I've been working with the Better Building Working Group down in Wanaka, on for a while, is how we do with waste timber from building sites. So we had a site down in Queenstown. That was a home-style project, so we tracked all the waste from that. We had 1.6 tonnes of waste that went to landfill. 1.3 tonnes of that was timber.
Yep.
Just off cuts and that sort of thing. Just off cuts. And that was a SIP build, like not a lot of timber in it as it was. The majority of that came from internal framing, and a little bit from mid-floors. But there's a huge amount of wasted timber, and there's nothing that you can do with it. It essentially just goes to landfill. Are you guys looking at any... Yeah, well, I mean, you try and use as much of it as you can. There's a lot of dwangs, blocking. But I don't want to encourage that either, because that's just creating thermal bridging. But if you guys are sort of, I guess, do you have a model? I guess what I'm trying to get to is, do you have a model, or are you looking at, or have you thought about a model where you could potentially buy back this waste timber for fabrication?
Probably the quick answer to that is no. I mean, I suppose that the structure and having it come from our mill is there's a huge amount of quality assurance that sits behind it. At the end of the day, it's a structural component, right? So we have to, the amount of data that we collect during the manufacturing process, especially in this facility in Australia that we have now, it's huge. It's mapping moisture content, the actual structural performance of the individual lamellas, the glue line integrity between those lamellas, the finger joining performance. At the end of the day, if we're building and we have done, 9-10 story buildings out of CLT, you want to know that every component of that is meeting a very stringent requirement.
What's the highest you've built? Just out of curiosity.
Yeah, that's a good question.
8 or 9 is probably the main for X-Lam in terms of projects that were supplied, some here in New Zealand and some in Australia.
Yeah. Cool.
Globally, there's, upwards of 15, 16, 17, 18 in the States, which is amazing. I suppose where that goes to that next level of height, vertical extension is in hybrid solutions. Atlassian in Sydney at the moment is building a big concrete CLT hybrid build. I forget the total number of stories, but it's upwards of 30. It's significant.
Isn't that the new fish market's a hybrid CLT building as well, isn't it, in Sydney?
That's primarily glue lam, so there's a lattice roof structure. Yeah. But there's steel and concrete components, Yeah.
So I suspect the one you're talking about is concrete columns and beams and CLT flooring or something like that?
Primarily a structural core. So obviously, if you create a core, especially for high-rise buildings, when you start to introduce like considerations for fire, what they've looked to do is I forget the number of stories within each compartment, but they've basically created, vertical sections of sort of call it 3 stories of concrete, and then the infills are CLT, and then they're doing that repeated nature.
That's awesome.
So I suppose that approach allows timber to be integrated in a way where if you just made that solely out of concrete and steel, which is possible, there's a huge amount of cost in terms of construction timeframes, back propping, curing times. The efficiency to build that is significantly improved by the integration of the timber components.
So this begs the question: why are we not using it more?
Cost.
I mean, I think it's probably, cost in terms of if you were to take one material and put it alongside the other, you're right, Ben. I mean, that's how it's perceived, and that's probably the biggest barrier at this point in time. I suppose, some of those reference points are just made there and around, a concrete floor. If you're laying a tray deck floor and infilling it with concrete and back propping it and leaving that to cure for, however many weeks, that's time, right? At the end of the day, in a commercial environment, time is money. And so I suppose that's the part that's hard for anyone, especially the supplier of timber, to sit back and go, the timber's definitely faster, because of course, it's perceived that would say that. But we definitely are seeing that in commercial applications. X-Lam were involved with a Hines as a global real estate organization, and they have a timber model that they've taken throughout the world, and they built one in Melbourne. It's called T3 Collingwood, and that had effectively 8 stories of concrete and steel, and then 8 of CLT and glue lam. And
as like a test,
that's just the design. It's repeated throughout.
It'd be really interesting. Sorry, just quickly on that. It'd be really interesting to know which was more efficient, or which 8-story sector was cheaper.
In terms of cost, that's just the point. So the actual cost of the materials on the base component were obviously cheaper up front, but the labour savings and the efficiency on the upper levels was significant. And so you put that into a global context and understand what that means for a project, it definitely has a place. And I suppose probably the key thing there is it's an education thing, in terms of understanding, getting those stakeholders involved in a project and getting the right people and the right knowledge in the room. That upfront sort of awareness around, you don't approach a timber building in the same way that you do a traditional, because it's not vastly different, but there's different considerations that need to be brought into the room and considered at key stages to allow you to do that upfront thinking and make meaningful changes. And I suppose if you put it into a commercial context where you talk about grid set out, timber alone, whilst it can span the same sort of 9x9 grid for a commercial application, what does that do? It increases the structural depth of it. So you start to question, okay, well, is that material the right use case for that application? And that's probably the better scenario for, I guess, the widespread use of mass timber. And that's looking at using the right materials for the right applications, I suppose.
In that same breath, or in that same vein, like what about acoustics and fire and that sort of thing? Like how does it stack up moisture? All these things that I guess timber is a little bit susceptible to. Like how does it stack up to counterparts?
I mean, there's a lot of perception around, timber. You put a piece of timber in your fire to heat your house, right? It burns. And I suppose, and that's, that's a lot what a lot of people think, right? But in reality, you testing, and there's a huge amount of testing that sits behind products like cross-laminated timber and glue-lam. But I mean, it actually performs very predictably in a fire case. So obviously, it chars and then it burns at a constant rate, or a relatively constant rate. And what that allows us to do is obviously during a design phase, you can allow for that. So you want 30 minutes, 60 minutes, you obviously scale those components accordingly. Code requirements in different countries, obviously timber is, with its group rating and surface spread of flame, that does introduce other challenges, but it can be managed with the integration of linings and that sort of thing. So what we often see that, fire does dictate, especially at height. So residential, it's very simple and very easy to leave timber components exposed. Ben, the Warrener house in Littleton would have all been exposed. Beautiful, and that's, I think, the initial driver for many people to use timber is to touch it, feel it. That biophilic aspect is, as we all know, the materiality of timber is a really, well understood thing in terms of the benefits for the occupants. But I suppose the integration of building code requirements sometimes dictates what extent of timber can be left exposed, especially if you're talking multiple stories. So, yeah.
Yeah, it kind of seems like a shame to cover it up when you're using it to celebrate the material. It just becomes, and then essentially it's just steel, right? And then you're only you're looking at different things to try and weigh up your options. But
yeah, that's right. And I suppose that, I mean, there's a design approach here, and there's developing technology around thermally rated glues and that sort of thing, which obviously allow timber to be left exposed. Intumescent coatings, which mean that the challenges around exposed timber elements can be controlled to a higher degree. And I suppose that aspect means that the ability to probably celebrate certain components of larger commercial applications is possible. That's not to say that every commercial project has to have timber encapsulated or concealed behind a fire-rated substrate or whatever. It's really project specific. There's a number of fantastic examples in New Zealand and internationally where timber is used in an exposed manner, and that's even at 10 stories plus.
I'll never forget when they started making us treat the timber for internal use.
For durability.
If you left it exposed.
You know how there's a whole bunch of rules and regulations around exposed timber, around kitchens and wet areas and that sort of thing.
Yeah.
So if we wanted to use, CLT or, for example, other timber products exposed in a residential house, then we had to treat the timber, the interior layer, which, as soon as you kind of have a treatment in there, it's just not, it's not as appealing, I guess. For
what were you treating
use.
it in, Ben?
No, so that's how it came treated, obviously.
Yeah, so most
yeah.
Is it all LSO?
No, we didn't. At the beginning, we didn't actually have to. Most of it was, it's so solid and robust. It would take so long to actually rot away. The thought of it rotting away is not a bit of MDF or anything. These panels were 70 mil thick.
Solid timber.
Smaller. A lot of them were 90 mils or something. It's going to take you 50 years of water just for it to rot away. You're worried about a bit of...
Yeah, you raise a super valid point there. I mean, durability, obviously, the quality of the built environment's critical, and that's what we sort of all do. And in many respects, we're contributing to that future environment and want it to last as long as possible. I mean, I think treatments, X-Lam, we use a treatment that's been developed by our sister company, Hind Timber, which allows us to be compliant to the New Zealand Building Code. But that aside, durability is down to good detailing and good design, right? At the end of the day, that's again using the right materials and the right sort of design considerations in the right place to ensure something doesn't fail prematurely. I think there's things like treatments are obviously a fallback for underperformance in designs. Look, you're never going to get around that from a building code point of view. It's essential.
I'm just really good at detailing, guys. I don't need to treat any of my timber. It's fine.
It's impervious.
Yeah. But it's I think that's a key part of you're building with any product, to be fair, is good practice in detailing. But yeah, Sam, you made the comment in around acoustics as well. I mean, acoustics, obviously the density of timber over concrete especially is obviously quite different.
Yeah.
But there are ways in new developing technologies that allow CLT especially. It's obviously the consideration for acoustics comes into play when you're talking intertenancy floors and walls in particular. There are ways around it to get overall wall build-ups to be compliant or exceed that. And, many of those are integrating existing approaches for, bend and cradle floors, but also there's other new products out of the States and Europe where higher density rubbers and sand and other things are allowing the floor build-up to achieve favourable acoustic performances, which is fantastic.
Yeah, I guess it's just that with any mass product, be it timber or be it concrete, like there's always just that concern. We even have that issue with SIPs, they acoustically without an air gap don't perform that well. So you need that buffer of something need to be able to break up the sound waves.
So what happens with the SIPs? Is it kind of like, because CLT is like reverberation, right? It's because it's so solid, it's like just vibrates from one space to another.
Yeah, so like tapping on it, you'll get that sound will transfer straight through it. It's the same as a SIP,
even through
really, because there's no air gap, right? You need air to break up contact sound.
So the insulation doesn't do much?
Nah, not really. Not for contact sound. So like rain on the roof, you'll hear that quite. I like it, but we've had clients, a few clients complain that it's a little louder than they thought it was going to be. But then airborne sound, the houses are airtight, so you don't hear airborne sound really anyway. But airborne sound also doesn't really penetrate through because that's when the insulation's doing its job, but it's that contact sound that's more of the issue.
So what's airborne sound, sorry?
So like a car honks its horn across the road, you're less likely to hear that because the insulation's actually, that's when it's working. But if there's a woodpecker tapping on the side of your wall or something, or somebody's, downstairs hammering something, you'll hear that through the structure a little bit more.
Yeah.
And it'll probably be the same with CLT, I imagine. In a world where design speaks louder than words, what story does your space tell? At Ortex Acoustics, they believe great design is more than aesthetics. Every product they create strikes a perfect balance between form, function, and sustainability, made to enhance how a space sounds, looks, and feels. From using recycled materials to pioneering carbon-negative wool, their commitment is to help you shape environments that inspire people and respect the planet. Explore the future of acoustics design at ortexacoustics.co.nz.
Yeah, CLT, remember the product that you guys used to make? It was like a double layer, the twin skin one?
Twin skin, yeah.
That was a good product.
Which was like 60 mil with a PIR. We don't make it anymore, but it's
insulation in between. It was like a sandwich.
Giant SIP.
It was like a giant
chonky SIP.
Structural, yeah.
Nice.
It was probably, we supplied a few projects and a lot of people still ask for it, but it's probably it's a different sort of space that we want to play in terms of pure production of timber. I suppose it starts to integrate, pre-assembly.
Pump it out.
Yeah, that's right. But it's I think that the performance, one of the things with, I call it an emerging technology, and it's not emergent. It's been used in Europe for 40 years.
Emerging,
and the southern, and that's just it. It takes a long time to weave new products through a full spectrum of stakeholders, right? Clients, designers. Think about how many consultants are in a given project these days. You've got, go into a design meeting and there's 50 people and they're all doing something different for the project, But it's, I suppose, the level of understanding and integration of those learnings across the board. It takes some time to adopt in a widespread manner. It does take time. I think as part of that, once people get sort of more familiar, they see better examples of probably landmark projects and also the use case in a day-to-day. There's something. It was one of the engineers from Dunning Thornton. We're on a timber panel a couple of months ago, and she made this really nice reference to, timber. You can build ball gowns or you can build t-shirts, and I think that's really nice because everyone marvels at the ball gown because it's beautiful and it really shows the capability of timber and the advancements of machining and design and all that sort of thing. But from a widespread use case, if you could find a position where the residential market is using CLT in a well-suited case on a mass scale, that's where the level of understanding and interaction becomes, so much more engaging.
Well, that's what RTA are doing with their
that's
new project.
Such a cool. I'm kicking myself because I'm like, I should have bloody done that years ago, and we definitely tried. But kudos to RTA. That's like
it's awesome.
Such a slick design.
And focusing it on that, that affordable housing sector as well.
Yeah.
And it's sort
100%.
of like, okay, if it can hit this mark, and it sort of pushes that affordability, that price complex that you talked about earlier down the road a little bit. It'll help residential architects like myself go, oh, well, why can't I use this as a solution? I know, George, you've been drumming me up for a while to try and use it, and
haven't got you over the line yet, mate.
You haven't got me over the line yet, and I would love to. Like, I honestly would love to, and I keep thinking, starting to think about the design aspect of it. I think the initial, from a designer's point of view, like initial reluctance, I guess, for us to adopt it is a lack of understanding of one, what the product is or how it can perform or how we can utilize it. Is there not necessarily just X-Lam, but like in the wider, obviously X-Lam is where the perspective you're coming from, but in like the wider mass timber realm, like is there that design advice and assistance there, even at a small scale, like if we were to do like individual one-off houses?
Yeah, well, and even deep, like, are people actually still using it in the residential sector? Is it that common now?
100%. I think, we're seeing a huge cross-section in terms of use cases. I mean, resi, like typically high-end is where you get very bespoke and you start to lean on the capabilities of what CNC machining offers for projects in terms of, complex geometries and, really, really looking at ways that you can really emphasize the capability of mass timber and the advancements that it brings. But I suppose we're also seeing a lot of, call it mainstream builders, and we've just referenced the RTA example where people are going back to looking at using it just for mid-floors in their residential applications or just for sub-floors if they're on a sloping site. And I think that's really encouraging. Whilst RTA as an example, they were also involved in Scion and they're involved in Fisher and Paykel. These amazing examples of
pretty detailed understanding of the product before they even got there.
100%. But not everyone's building global headquarters, but everyone is building homes, right? And that's the really, going back to that ball gown versus, though the RTA version is sort of more inclined to be on the ball gown side because they do some pretty cool designs, but it's mainstream versus kind of one-off bespoke applications. And I think that
it's more like a nice t-shirt.
A nice t-shirt, yeah.
Oh, yeah, that's cool. So I guess like one of the benefits of using it in residential to make those nice t-shirts, I'm not sure if you can actually do this, but like once you've kind of got that file set up and you've like run it through the system and you basically have that cutting blueprint, it's more or less just a rinse and repeat. Whenever you want the same thing, you can kind of just
cut and paste,
find a little gap and run it through the system, right? Does that sound about right?
Yeah, and in fact, from a manufacturing point of view, and it's not unique to X-Lam, it'll be the case for many. Having the ability to have standardized, products that you can pump out in terms of projects, so you're working with a housing developer who's got a standardized design. If you can make that with a compressed lead time without any coordination and shop drawings and all the stuff that is typically involved with these high complexity projects. Perfect. We could make it tomorrow, so to speak, not necessarily.
Yeah, because you'll have lag time in your production process as well, and it kind of just slots into those gaps nicely. And that
100%.
ultimately makes that entire product super efficient from all perspectives, really.
Yeah,
I always thought that the medium density market would benefit from it a lot more than the one-off residential.
Time to start using it again.
At the very least, you're building whatever 5 or 10 of the same or similar thing, right?
Yeah. There definitely are developers that we work with in that space who that's their core focus. They use CLT mid floors all day, every day, which is that they've just got it so ingrained in terms of their design approach, the efficiencies that it creates in terms of install of those components on site. For one day they're standing ground floor frames, then they've got CLT, and then they're on the next level the day following. So for them it feeds into that site component around efficiency, which is awesome. CLT and Glulam and those products which have high alignment with environmental considerations. What we're typically seeing is, we've got EPDs and everything that backs up the environmental performance of our product. That maps the everything from the forest to the factory gate, basically. And so that's, tree regrowth time, etc. In terms of the living building challenge, you have to have a whole lot of considerations for reuse of that building after its natural life, basically. Looking at ways that you can repurpose, say CLT floors or something and reuse them in another building.
Yeah, just a whole bunch of tables.
Yeah. I mean, why not? It's still
tables,
reuse, right?
Chairs and staircases.
The reality of that might not be as refined as what is thought at that stage when they're pitching to get credentials, points for a environmental thing. But at least it brings it to the forefront in terms of environmental consideration. You start to think, well, if we did this, maybe it could be used as a floor in a house or something, which is cool.
Yeah.
I think that's quite powerful. But construction sector, is one of the biggest emitters to negative environmental impacts.
40%.
We've never sort of really thought about that. Sam, what was your number there?
40%.
Oh no, yeah, 1.5 tons of timber offcuts or something, or cubic.
Yeah, 1.3 ton of timber.
Yeah.
Out of 1.6 ton total waste, 1.3 ton of that was timber.
And that's one project. You think about that. You can see why that number of 40% as an industry is so high.
Yeah, we've done over the years a lot of 3-axis CNC routering, and so that's essentially you put a bit of plywood and on a sheet, which is typically 2 4x12, and you cut out your shapes and whatnot. And part of that process is nesting, so how you determine what the most efficient use of the material. One of the good things I always liked about cross-laminated timber was, there's obviously like an element of trimming, but it's more or less cut to, or it's kind of impressed to fit the actual component it's going to turn into. Does that make sense? So it's like design, it's like cut to suit. There's not even like dwang's worth of waste, essentially.
It's not like you're getting delivered a bunch of 3/6 length timber or 6 meter length timber.
You're not getting 1.600
off each one.
Exactly.
Yeah.
These are the lengths that we need. Let's build it together. We'll trim the edges, and that's that. Which was quite efficient, really.
Absolutely, Ben. I mean, and the reference to nesting there, that's the key to it, right? I mean, we have ability to create large billets, and then we typically will make a billet to suit a panel, but we've got examples of projects where CLT hasn't been used as a 3 by 6 meter component. It's triangles or something some odd shape and configuration that it's going into. And so as part of that, we've got the ability through our modeling software to optimize that configuration so that the waste is absolutely as close to naught as possible. Not always,
that's cool.
And that's not possible. There is a waste part of CLT production, but the cool thing that's part of things like EPDs, it's mapped, right? So what we now do is we have waste streams for all of our offcuts. In Australia, we've got a good relationship with a contractor who comes in, collects it all, mulches it up, and uses it for bulk supply of mulch and sawdust for horse stables and that sort of thing. So that's 100% recyclable, and that's
pre-treated. I hope.
Our treatment has been tested, so we've gone to the length to test the ability for that to be used.
Right, cool.
So it's got a declare red list free treatment, which, again, it means that none of that's going to the landfill, which is, so
that's huge.
You take into consideration, Ben, the point you made around the panels coming to site with no offcuts, and then even at a production level, we're able to reuse the offcuts that are created during manufacturing. That's super efficient, which is really amazing to be able to be involved in a product where there's that level of consideration for that cyclical nature of the product and reuse.
Is part of this podcast, I don't know if Sam told you, Jordan, but you're actually required to take us over to Australia and conduct a tour of the factory.
Yeah, it's a deep dive.
We also have to, step inside the 5-axis router to experience its vastness, which I actually did.
We actually make sure we turn it off then, mate.
What is the limitation on size of a panel?
Seriously, if you're ever in Australia, come and have a look. It's an amazing thing to see. Like that level of optimizations, it blows me away even when I go there on a regular basis. It's every manufacturer obviously has different machinery that they use and different suppliers of those systems. And so that typically dictates the production output. So as an example, we can make panels 3.44 is the exact dimensions by 15.7 meters long, which is a big panel. And that can be, 310 thick, right? So that's
what's the most efficient panel to make?
Man, that's big.
Yeah.
Is that the most efficient? Like 3
Not
meters
necessarily.
by 15?
So there's a whole lot of other considerations around panel size versus, if you've got a project that's in Queenstown or Wanaka as an example, there's no way you'd make an oversized load because you have to.
You're not getting it there.
Well, you get it there, but at a huge cost, right? But
helicopter.
Yeah. One at a time. Whereas pulling that within gauge as an example under 3.1, still a very big panel, but obviously you're controlling that freight component.
Yeah.
But by all means, if there's a project within a close proximity to a production facility, makes complete sense to maximize that if you can. But then you're also governed by things like craneage. I mean, a 3.5 meter by 50, that's a good 4 or 5 ton, depending on the thickness. So you do need to factor those things in. And that's why I say before around having early involvement, early engagement from stakeholders and making decisions up front, that feeds into the way that we would supply a project and go through the shop drawing and production phase. But in terms of that efficient panel layout, Ben, I mean, from a thickness point of view, it's not necessarily the thinnest is the cheapest or the best to produce or the thickest. It kind of varies throughout our range, and it's dependent on the feedstock that goes into it. So if we have to change the lamella thicknesses and arrangement, then obviously it adds time and, not complexity, but it just adds time into the process, which carries cost, I suppose.
Yeah. And are you guys only doing pine?
Australian radiata grown pine. Yeah.
So it was all your forestry it was all production and all forestry for X-Lam in particular in Australia now?
Yeah, that's correct. Yeah. So as part of that, it's interesting. A radiata pine tree grows slightly slower in Australia than it does in New Zealand, which means it's a little bit stiffer, different climate. But it's, I think that as part of that, we've, with the vertical integration of our business, it's all aligned from, all the supply comes from the Hind Timber mills, the forestry agreements that are in place for Hind Timber, long established. It's a reliable source of feedstock. So yeah, it is all very much an Australian grown and supplied product.
And are there any new and exciting innovations that you guys are kind of working on as well, other than obviously just CLT itself?
I think one thing that, and I haven't been in X-Lam this whole time, but obviously, as we referenced at the start, we've been abreast to it for a long time. And I suppose one thing that's interesting is whilst the capabilities of machining and everything has gone, it's still forever increasing and improving. And I referenced it a couple of times earlier that probably the the getting back to basics and doing the simple things really well is actually probably more a focus right now.
Yeah.
Because, give us the most complex thing, we can make it, but it's not necessarily what drives a manufacturing approach. You need the level of reliability and predictability and refinement that allows a production facility to drive volume. And so there's a lot, it's easy to describe it that way, but the reality of that is quite a bit different. And so that for us has been a key focus.
It's something you guys don't really control. It's a focus for sure, but it's almost on us as architects or designers or engineers or, the 100%. People that the user or the specifier of the solution to start to be a bit more experimental or start to use it.
Yeah.
Or less experimental.
Or less experimental. Yeah, just kind of exactly take it back to passive.
Yeah. And look, that's not
be less experimental. That's how you can
just chill out, guys.
Rebuilding needs in New Zealand and Australia needs to look identical. Yeah, no, and that's not to stifle design innovation by any means, but I think if you look at take some learnings from stick frame construction, right? It's the reason it works so well and it's so widely used is because it's pretty basic and it's well refined, right? And you take that mindset and overlay it in terms of CLT and Glulam and those kind of newer mass timber components, then you start to really drive volume and get the use case of that product slightly more widespread, I guess. Yeah. But in innovations, you've always got to be innovating. I suppose, you probably look at your own businesses and what you do day to day. I suppose 10 years ago, were you doing the same thing?
Shit, no. And then, completely not. Not even 3 years ago.
That's it.
I was so much more innovative back then. I feel like I've lost it and the last 10 years figuring out how to refine it. Refined maybe, but definitely not innovative. Yeah.
Yeah. It's through innovation you learn what also doesn't work as well, Ben. So maybe you've had that mindset up front and you know what works.
Yeah.
But to answer your earlier question, as a business, we're always looking to innovate and, try new things in terms of, new products, new ways of streamlining our processes, always looking at new ways of doing things better.
Bigger machinery.
But I suppose the thing has been, those things are always there. You can always throw money at something to make it happen, to get your return and your and value out of those investments because they're considerable, right? It's about using them as efficiently as possible. And even for us, we've been in business for longer than others in the Australasian market, and we still haven't reached our maximum capacity. So there's a long way to go, which is exciting because it's only up from here.
We've talked about the barrier in terms of your own or the business innovation side of things and then the design point of view. But what about the trades? Is there a barrier for more pickup of this due to a lack of skill set or understanding or whatever around the actual constructing or the assembling of CLT panels?
Initially, yes. People don't want to deviate away from what they know, right? And at the end of the day, it's timber. And if a builder's not familiar with how to trim a bit of timber, then they shouldn't be on a building site. But I suppose many probably were somewhat apprehensive to engage with it. But as part of that, as part of kind of mainstreaming and seeing how simple mass timber can be and what level of kind of familiarity can be drawn from what they do currently, that's where there's a high degree of confidence. For us, we typically see if we're previously X-Lam in the early days, we were involved in installs. And as part of that, we would typically align with main contractors and, as part of that, they would be on site as part of that install journey. 2, 3, 4 iterations down the track, they're installing it themselves, right? So it's just a learning thing, I guess, at the end of the day, understanding the nuances of the material, the weights, the considerations are on site, having key, certain specific equipment to install it and move it around. But it's timber at the end of the day, and it's easily managed, which I think, especially in New Zealand, we're seeing the uptake of that at a residential scale, especially, which is awesome. So I'd say still some work to do there in the trade, Sam, but I think it's definitely a growing space in terms of that familiarity.
Do you guys offer training in that, in that realm?
Yeah, so we have a lot of project managers as part of our business. So there's obviously we split things up into pre-construction, which is anything to our factory, and then there's obviously the delivery component that involves logistics and advice in terms of install sequence and methodology and that sort of thing. So yeah, absolutely. I mean, we as a business would support that. It's it only but helps the use case of the product really.
Right, just got to find a project now, then, Jods.
Come on, mate.
Jordan, do you think that Guy Marriage, our beloved thesis supervisor, has any students that are working on using AI and the combination of AI and cross-laminated timber to design some really efficient buildings?
Cross-laminated timber aside, I mean, imagine what art school's like these days in terms of getting stuff done. I just think that whole design world would be a different space now than it was, when we were there. But look, I think at the end of the day, going back to the discussion we had before about innovation and tools, it's a tool to do things better, right? I suppose absolutely there'd be parametric, AI tools that would allow you to optimize design and grid setouts and all sorts of things.
That would have been fun.
Would have saved you some time, probably.
Would have saved us a lot of... it probably would just been different headaches.
Yeah, different headaches.
More exciting headaches, potentially. But I'm sure it's actually happening. I mean, why wouldn't it be, right?
Of course, yeah, absolutely. You'd think so.
On that design side, and because you were an architect first, trained as an architect first, George, do you have a favourite CL2 building?
I've got
many, the Warrender Studio.
Oh, you've got me, mate.
Yeah, that was it. I knew it all along.
Honestly, Sam, I think when we started off this discussion around Ben and I going off to the Prefab NZ conference while we're doing our thesis. For me, timber, I've always loved timber. It's something I grew up with my old man building things growing up. And I suppose
you were raised at ITM, weren't you?
Plug, yeah, no, that's right. Stacking 90 by 45 framing and filleting timber to be dried and all sorts of things. But as part of that, I've always had a close association with timber as a material. I even look back at prior to thesis year, all my design projects at uni, they always integrated some level of timber. It was just me. I suppose favourite projects, Sam, to answer that question, I actually just love going on any timber site. Whether it's a small resi project or a Scion or I haven't been on the Fisher and Paykel site, but these amazing landmark projects. Absolutely, you sort of marvel at what can be achieved with timber. They just have
go inside and just take a big sniff, breathe it in.
It sounds a bit crazy, but I don't. There's something special about a timber project, especially a large commercial one. So we're lucky to have been involved in projects here in New Zealand and Australia where varying levels of complexity, scale is the next thing, which obviously is somewhat awe-inspiring when you stand there and go, "This is timber." At the minute, we've finished our involvement, but we've just supplied a 100 metre clear spanning timber hanger for Air New Zealand in Auckland.
Seen the concepts for that.
You stand in that thing and just think that's timber. It just your mind boggles.
Thanks for your time, George.
Thanks, guys.
Thanks for coming on.
It's fun to chat. Good to
it's good to talk about timber.